So really excited to give this talk. It's honestly, last week I was like, is this talk going to be completely out of date given how fast everything is moving? But hopefully, you'll at least, sort of get some information out of this, some intuition about what's going on and what is generative AI, what are some interesting ideas around how to use it. And then, every week there's more and more breakthroughs, and I'm sure, this talk will be outdated in a few weeks. But hopefully folks find things useful. Just because people have very different exposure to generative AI, and I know this is generally an expert audience, let me just kick it off before diving in with like two questions. One is, how many people here have used ChatGPT, right? That's the most common thing. Okay, so basically everybody, that's right, that's the exposure to generative AI in the most popular sense. How many people have gone beyond ChatGPT and actually used, for instance, like the OpenAI playground, where you're actually interacting with the underlying model? Okay, so maybe 30-40% of people have done that. And how many people have actually built applications where you actually sort of started to use those APIs, thought about the real world implications of how to embed them into applications? So maybe 10%, 20%. Okay, so I will try to gear this talk. I have a lot of slides, and I'll try to gear this talk to sort of that crowd. I'll start off with a little bit of so just high level stuff, but then hopefully I'll go in depth for even the people that are a little bit more advanced. So today's talk, generative AI for product builders. If you want to build products, kind of what should you know? Who am I? I got an introduction already, so I don't need to repeat this too much. I'm co-founder of Continual, which is a startup that basically started with the idea of like, hey, is it possible just to describe what you want and get the result? Is that the end state of AI? Of course, this got completely disrupted with the rise of generative AI in the last year, and so now we're deep into thinking about how that affects what we're doing. If you're interested in it, go check it out. And the net of my introduction really is that I've experienced the pain and suffering of trying to make AI and ML easy, especially using like the traditional ML ops approach. And I spent like 10 years doing that. And what gets me honestly most excited about generative AI, in addition to all of the capabilities that it unlocks that just fundamentally were not possible, is the elimination of the complexity around ML ops and how much it enables product builders to build amazing products remarkably quickly. And hopefully that will be clear, I think, through the talk. So what are what are today's goals? So I'm going to talk about a few different topics very quickly. I'll try to go through just what is generative AI and give you some intuition about that, starting with ChatGPT, but then going much beyond that. Why do I think it's exciting? And then the heart of the talk really will be about what are the key challenges for product builders, give you some examples of key challenges, workarounds that are possible or things that you can do to address those challenges, or at least a sampling of workarounds so that you gain some intuition around, okay, if I have this type of challenge, kind of where should I be looking? And I would say each one of those solutions, it's changing day to day, but I want to give you some concrete examples of that. Like look at some research papers that I think are super interesting, being like, hey, what's the core insight of this research paper? And I think if you kind of look at 6 or 7 research papers, you'll kind of be like, oh, I kind of get how people are solving these problems. And I would say one thing that's remarkable is that you can have equivalent insights to some of these papers. Some of the insights of these papers, after the fact, are actually very, very small. And so if you kind of get exposed to a few of them and get an intuition around them, when you confront your own set of problems, I think you can think creatively about it and very rapidly, which is fun, which is honestly a lot of fun. Where coming from a previous world, right, where you would spend months and months and months trying to implement things and then have it fail or be non-deterministic or whatever. Finally, I'll talk a tiny bit about promising product areas. I think this one, people talked a lot about at the previous panel discussion. Happy to talk with people more about their own ideas, questions. There's an office hours after the fact. Okay, so let me jump right in. This is super high level. It sounds like everybody's had, what is generative AI? It sounds like everybody's had exposure to ChatGPT. So we can, of course, just ask this question because I'm lazy and I don't want to write my own definition of generative AI. So we can, of course, ask GPT-4, the latest model from OpenAI, what is generative AI? And so GPT-4 says, generative AI is a type of artificial intelligence that creates new data such as text, images, and audio. Okay, so they're saying it's multimodal, which is true. It's not just necessarily large language models. By learning patterns from existing data. That is a very loaded sentence there, but eventually, you can think, okay, it has a lot of data, looks at a lot of data, and then it learns patterns about those data. And then using algorithms like deep learning, neural networks, it can generate realistic and creative outputs. Okay, generate, there's the word generate. So it can generate realistic output and creative output often resembling human-like creation, so like this description right here, which is a generative output. And applications include image synthesis, natural language processing, and music composition. Okay, so this is obviously not the only definition, and I like it, but I think that you can not see the sort of the profound implications of generative AI if you read it like this. I think once you start to build products and start to do use cases, you realize it can be applied to generating text, and generating output can be applied to an incredibly diverse range of tasks, including very traditional tasks. For instance, spam classification, because you just say, hey, is this spam? And it can generate yes or no, or spam, or not spam, or promotion, or newsletter, or whatever. And you have a classifier right there that if you look at patterns of data, and you generate some text, that generating text could actually be something that you would traditionally if you're from a traditional machine learning background, you would think of a traditional task like classification. So I think from a product builder's perspective, I would like to say that this is, generative AI is really a better, faster, and often cheaper way to build AI-powered products and features. And so that's really what makes it funny. Better, it's remarkable what it's doing. It's beating state-of-the-art fine-tuned models, as I'll talk about in a bit. Faster, well, I would say in terms of faster, not in terms of necessarily the inference generation time, but if you think about implementing a product feature, I wouldn't be surprised if it's 100 or 1,000 times faster than implementing something yourself. In terms of you really can solve a particular product problem almost instantaneously, at least you can prototype it. Whereas if you're coming from the traditional MLOps background, my background, any use case that you think of, realistically, it's going to take a lot of time. Particularly, it's going to take a lot of time to put it in production. If you actually think about putting a model in production, maintaining the lifecycle at monitoring, thinking about the edge cases and iterating on the edge cases, it takes a lot of time, a lot of effort, a lot of people. And then cheaper, probably because not cheaper always in inference costs, because these are huge models, but often cheaper from a human resources perspective, right? So as soon as you hire one ML engineer, just think of there goes $300,000, $400,000, right? Maybe $600,000. And so, often cheaper from that perspective in terms of the ability to do this quickly and to do it. So very exciting, I think, from product builders. Okay, but this is an example of generative AI. I put in some text here and I generated some output here. But how does that actually work? So we had a ton of people who've interacted with ChatGPT. The next stage in your evolution for playing around with these models is to go to the OpenAI playground, which is basically a place where you can interact with the kind of the raw inputs of these particular models. And you can get a feel for how something like this was built, right? Where I have an input and then I have a completion. And so if I go here to the OpenAI, so if I say, okay, how did that previous example work, right? How was that built? How was that built on top of generative models? Here's what this looks like sort of behind the scenes, and this is GPT-3. It's not this new interface that they have with GPT-4 that's more of a chat interface, but this is the core. Even that chat interface behind the scenes is doing something like this. So if you haven't experienced the playground is you basically type in some text, okay? That's called the prompt, and then we simply say, okay, how do we complete that prompt? What would be the most natural extension for it? And so in the case of a chatbot, a prompt that I might generate is something like this, where I say, the following is a transcript between a human and AI, and AI always responds with a helpful message. I could say something like funny message, but I say helpful message, and then I say human : what is generative AI? And then I say AI : and then I say, hey, model, big neural net, complete that, okay? Tell me what is most likely to fall, given the patterns of data that you have observed, and we'll talk about the training and how this all works, but given the patterns of data that you saw, how would you most likely complete this? And if I do that and hit tab, I like doing this live, but I unfortunately can't do this live in this example. This is what OpenAI's GPT-3 or Text Da Vinci model, which is the previous generation of models, would generate. A generative AI is a type of artificial intelligence that focuses on generating new content based on existing data. Very similar, and then it goes on to some applications, right? So actually very similar response and completion to that completion that I just got with ChatGPT, okay? If I parse this and I put a chat UI on it, I've got a chatbot, right? Because then I go human : and the human says, well, what do you mean expand on this fact? And then it says, AI : complete it. And the AI will look at all of that text and say, hey, given all the data that I've observed on the internet and all the data that I've observed and the patterns that I've observed, what would I think most likely follows that? And it's a little bit more subtle than that. People that know how these models work, it's a little bit more subtle in terms of how this model works. But generally, the core idea is, given all the patterns of data observed, how would I complete it? And what you realize, I think the observation here is that completion, this idea of you have a prompt and then you complete it. I just built a chat bot. Okay, so the big thing is think creatively about how to map your problem into a completion domain where you say, here's an email message, is this, this one is spam, here's another email message, is this spam, yes or no, and it will complete, and it will do a pretty good job of saying yes or no, and completing in terms of yes or no. Your responsibility then as a product builder is to parse this general text, probably put it into some JSON format that's not just a big blob of text, and then put it into a product feature, okay? But this is the intuition here that everybody, the first thing is go around and play with the playground, get familiar with this idea of completion. This little, pop-up here is telling me if you want, you can ask GPT to give you the probabilities of the next token, right? So this is the probabilities of this last token here, composition. And you can see, you could say music composition, generation, synthesis, production, and there's the probabilities there. And so it just is taking the top probability token, or depending on some parameters, maybe randomly choosing the final token. Okay, that's at a really high level. Now, a bunch of people here have used the ChatGPT playground, so let's go a little bit more in depth in terms of how that worked. So the paper that sort of really kicked off this excitement around generative AI, and there are many previous papers, the Transformer papers, and when GPT-2 came out, was this paper on GPT-2 that was called "Language Models Are Few-Shot Learners." And you can see in the title that part of this excitement is obviously this few-shot learner concept. There's really two parts to this paper, and this is now a couple years old. The first part is that it's possible to train a very, very large autoregressive language model, where autoregressive just means like given the past inputs, I can predict the next token or the next word, in a fully self-supervised manner. And fully self-supervised means I don't need human labeling data. And so you can basically train a very large model on a very large amount of text. So that's one observation. Hey, you can train these extremely large models. This is a 175 billion parameter model. The second thing that it did is it said the resulting model demonstrates few-shot performance in translation question in a bunch of tasks. Okay, few-shot performance. And that was the heart of this thing, and sort of the novel insight that I think people didn't previously realize, and kind of what maybe even wasn't fully realized until the ChatGPT world came around. But it's this idea of few-shot learning, which is really a complete transformation of how to think about learning. And so let me talk about both of those points just in a little bit more depth so that people have an understanding of this. So the first point there is, what is self-supervised learning? So GPT-3 has a particular form of self-supervised learning that's focused on next token prediction. So given a sequence of text, what is the most likely outcome of the next token? And if you think about that deeply, in order to do that task really, really well, okay, there's an argument that you actually need to understand the world incredibly well, right? And so a lot of people say, oh, it's just memorizing stochastic parrots, and there's truth to that statement in the sense of like it's just generating the next token based on what it's seen in the past. But then if you ask yourself very deeply, well, how would you do really, 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 really well on that task, right? You would need to deeply understand what the text was referring to. You might need to understand physics, right? You might need to understand mathematics. You might need to understand all these different topics. That would be helpful in determining, hey, what is the next token, or what is the next thing to believe. I think there is an interesting analogy to evolution. Like if you think about the rule of evolution, it's incredibly simple, right? Survival of the fittest, and look at what it created. So I would say be cautious of saying that because there's a simple objective, simple stuff is what emerges. It could be that incredibly complicated stuff emerges, and I think we're already seeing signs of that. So that was a little bit of a sidetrack. I think the core point here I wanted to make is that self-supervised learning is really a form of how do we use all the data that's on the internet to train these large models without generating labels. And the core idea here is really about creating noise in your data and then filling in the blanks. One way to do that is to chop off the last token and predict the next token. This is an image from a paper called UL2, which is from Google, which is saying, hey, there's a bunch of other versions of this, right? You can take a token in the middle of your sentence and you can try to fill it in. You can take a block of text in the middle of your sentence sentence and you can try to fill it in. You can take a long, completion at the end and try to fill it in. You can do a lot of, you can change the amount of noise or tokens that you've eliminated and then try to fill it in. In all of these cases, the model needs to understand the world, understand text to be able to fill it in. And these are basically different objectives that you can generate at massive scale across all the internet, all the data on the internet or all the data that you can possibly do. And it's a sort of a task that the model has to become better and better at. GPT-3 does the next token one, but there's actually, this paper says you can save about, a huge amount of compute if you do this, and, then there's some caveats in terms of the usage of this model downstream, but it's an interesting idea, and I think illustrates the general point that next token prediction is just one objective that is a self-supervised objective. So these are self-supervised models at the core. Now there's people in this crowd that are thinking, other things like reinforcement learning, and we'll get to that. So the second observation that's important for these particular models is this few-shot learning case. And here's what few-shot learning is saying. So in a traditional world, so what does few-shot learning say? Few-shot learning say there's something called zero-shot, which means, hey, you have an objective like translate from English to French, and then you get cheese. That's the prompt. And you're saying, given this prompt, just do the task, okay? One-shot is saying, I'm going to give you one, there's no data point here, right? So there's no traditional data point. There's no example of an English to French or a French to English translation there, right? There's no data in this task. And so that's why it's called zero-shot. In one-shot case, you're saying, I'll give you one data point. I'll give you one example of this to this. And from that, can you infer the task that I'm trying to give you? And can you learn somewhere deep inside this neural net, there's something that knows how to do translation, and it sees that and it goes, oh, I can generalize from that one data point that you're now doing a translation task. And so that's called one-shot prompting. Few-shot prompting is say, hey, generate a few shot, give a few examples. And when I talk about prompt engineering, this idea of using examples or few-shot prompting is a compelling way to do prompt engineering, as I'll talk about. The radical idea here, though, is that you're doing essentially in-context learning. You're learning in context, it means within the prompt, the model is learning what you want to do. Okay, so the training data is very small because this model has all this background information, and it's happening in your inference paths. You could think of like during inference, it's going, oh, I know what to do, and now I'm going to figure out what to do it. Now what I'm going to figure out to do. That's very different than saying I got to train a lot of data on machine translation, and then I'm going to train a model and have a specialized model. That other approach, which would be fine-tuning, right? If you have a lot of data and you want to fine-tune your model, you would typically show it an example, and then you go to your model weights and you tune your model weights, right, to make it better at machine translation. Okay, so the big observation of the GPT-3 paper is that we get amazing results actually with this few-shot prompting. Okay, so what's exciting about this? So what's exciting about this is twofold. The first one is that it's incredibly capable. So not only can we generate all these new use cases that we haven't been able to do, like chatbots that are incredibly fluent. This is a bench. Oh man, oh no, okay. I was like, did I just get the wrong slide? No, I'm looking at my preview slide. So it's incredibly capable. What's the data to support this? This is an image from the GPT-4 paper where they're showing the exam results on a whole bunch of AP exams and a whole bunch of exams you would know. And remarkably, GPT-4, scores, which is the green lines, scores about between the 50th and 80th or 90th percentile on all of the traditional tests that you do, right? So if you give it an AP bio test, it will actually score, not superhuman yet, but extremely, extremely well across an incredibly diverse range of tasks. So this is in terms of kind of human tests, right, which have very rich question formats. In terms of ML benchmarks, this is a set of traditional ML benchmarks. For instance, the top one here is a multiple choice across many, many different domains. And the remarkable thing about GPT-4 and GPT-3, but GPT-4 is this column right here, is that GPT-4 in most of these examples, okay, evaluated with just a couple few-shot examples up front. That means like give it a few questions up front where it says, here's how I want you to answer. I want to give you a few multiple choice, so I'm doing multiple choice test. But this is a very general model. It actually beats the state-of-the-art models in literature by a very significant fraction without, even if those state-of-the-art models are fine-tuned for that particular benchmark, okay? Which is pretty remarkable, right? People are competing over these benchmarks and these models are beating them. Okay. So the lesson here, right, is that a very, very large model seems to be good at a very, very large range of tasks. And there actually seems to be a benefit to knowing all those different tasks versus specializing on a particular benchmark and specializing on a particular benchmark. That background knowledge is really actually useful to train on that background knowledge, and you're actually getting state-of-the-art results. And state-of-the-art results from just doing prompting, not doing any training, right? They're just giving it a few examples of multiple choice and then asking for completions, and you're getting state-of-the-art results across a huge number of benchmarks. Okay. So that gets to the second thing that I think is sort of disruptive about this, which is that it's incredibly easy. And by incredibly easy, I mean, look, let's say that we have an example like this. Here's a Yelp review. Here's a Yelp site that I just grabbed from a taco place. And I mean, there's a lot of noise up at the top of the page. This page, you could be a product manager and you could say, hey, wouldn't it be really nice to have a description of every single restaurant out there that kind of is a human readable, like this is what this restaurant is, okay? Now Yelp is probably saying, hey, I don't know what's great about these restaurants. I don't want to hire a bunch of people to go and write up a review for every single restaurant, right? Now what they do have is comments, but comments are not reviews of the restaurant in a nice neutral Yelp editorial voice, right? So you don't really have a solution. Well, traditionally, you might, if you wanted to build this, you might say, hey, I want to build a traditional MLOps stack, right? Here's Uber's MLOps stack. And if you do that, you might say, okay, the cost-benefit analysis of this, and even whether I can generate a nice summary, coming out the end here on the prediction part, it's going to certainly be a lot to maintain, right? And I don't even know if I can pull it off. Well, for me, I'm like, hey, no problem. Let me build this, let me just demonstrate that I can build an awesome version of this feature. So I just hit Command A, Command C, right? Copy all the text on that Yelp page, which includes a lot of garbage like the copyright and stuff like that at the bottom. That's the part up, okay? And I just literally copied and pasted that page. I dropped it into the prompt here in the OpenAI playground, and then I said, please summarize this web page above with a short blurb, no more than 100 words, describing the restaurant and its highlights, okay? And if you look at the results, they're pretty good. I mean, Cuantos Tacos is an Austin, Texas-based Mexican restaurant serving Mexican-style street tacos. They specialize in tacos and quesadillas, using 100% nixtamal. That must have been in part of somebody's comment. Outdoor seating offers a chill Austin vibe, and staff is friendly and helpful. I mean, honestly, it's probably better than your average person that you're going to hire to write that review. And I didn't even do any prompt engineering or anything special. I just, off the top of my head, I just thought of that instruction and then got that result. Boom, roll this across all the comments, all the whole database at Yelp, and I've got that great product feature. Do a quick A/B test, see if it leads to whatever more engagement, right? And we can roll out this feature, which is remarkable in terms of its ease of use. And so I don't underestimate that as a motivation to use these models, right? Okay, that was all hype. And excitement. I guess what are the key challenges? And I'm going to power through this because I have a bunch of, I think, challenges and kind of cool ideas, and I really just want to give you kind of like a flavor for what the key challenges are and some of the solutions, and I encourage everybody to dive much deeper in. So the first one is, do these models do what you want them to do? Do they generate, or do they follow the instructions that you want? Do they achieve your objectives? And this, under a broad term, this is called alignment. There's some people that think of this word as like AI safety, but and like our AI is going to become terminators, and that's a form of alignment. Hopefully they're not going to become terminators. But it's also just like, hey, like I want these models to be useful to the task at hand. And so that term here is basically called alignment. And there's a bunch of papers in this. There's a bunch of ways to do alignment. One thing to be aware of is this idea of reinforcement learning with human feedback. And so I kind of simplified how OpenAI and ChatGPT work by saying it just generates the next token. What they found is, yes, generating the next token is great, but what that means is when you put in, if you just use that, what it means is that if you put in a prompt, you should think of the completion as being, if I found this text on the internet, what would likely come next, right? And that is a very weird thing. Like, what comes next is not the answer to that's not a summary like I just did of the Yelp review, right? It's like, if you just randomly found that bit of snippet and the internet would then write something after it, what would be the most likely completion? It's not actually following the instruction. And so what this paper did, which is called training large language models to follow instructions with human feedback, was it says that, hey, the observation was we can significantly improve the usability of the models, not the performance, okay? The performance is still mostly coming from the base model, but the usability of these models by changing the objective to say, let's complete the next token, but do it in a way that we assume the prompt is an instruction, like, hey, summarize this review, and let's have it be really good at following that, following a human-based instruction. And what they found was, they trained this, and I'll talk a little bit about how they train it. What they found was if you train a model using this approach called reinforcement learning with human feedback, a much smaller model, a 1.3 billion parameter model, which they called Instruct GPT, was preferred over this larger raw base GPT-3 model. Now, the current models on OpenAI are all instruction fine-tuned, or even chat. They have another fine-tuning with reinforcement learning that uses this chat-based interface. Intuitively, what is reinforcement? You're probably not going to do this. It would be my guess as a product builder, but it is something to just get some intuition around, because you may, if you're very serious about it, you may want to do this. What does reinforcement learning with human feedback look like really quickly? It has really 3 steps. First step is you give an instruction like summarize, this review. You collect some data from expert users that samples this, that generates like, what you think the desired behavior should be. Then you fine tune the model, okay, which is just fine tuning a supervised training model. Then you generate a prompt like summarize this review. You generate multiple candidate responses from the model. Okay, so the model generates, here's what I think the summaries should be. And rather than this costly task of the user writing out the review themselves, you instead use the model to generate some candidates and then have the user rate those things. Do I prefer this model versus this model? So it's a much faster human feedback mechanism by letting the model generate candidate responses and then rating those candidate responses. And then rather than use these models directly to fine-tune the result, which you could do, okay, in this particular case for OpenAI, what they do is they train a reward model. What a reward model is they try to train a model that mimics the preferences of human beings. They try to train a model that says, okay, given these two reviews, which one do I think would be better? Okay, so it's training essentially the utility function of the labeler. Okay? The benefit of training the utility function of the labeler is you go to a third step, and now you're trying to train that underlying model. And rather than have every single data point being labeled by a human, you actually have the AI label it based on the reward model that you trained in the previous step. Okay, this last step is reinforcement learning. They use something called PPO, proximal policy evaluation. There's different ways to do this, but they've found a lot of success on this. This is one way. If you do want to do this, I would say there's a lot of questions around. Well, I'll talk about that in a second. In terms of this is not trivial to do, particularly the last step right now. Although I suspect it will get easier. There's more interesting ideas. So that was with human feedback. There's actually if you're interested in this space, there's an extremely interesting paper from Anthropic, which is some ex-OpenAI folks on what they call constitutional AI. And they make the observation that AI itself can be the labeler on a much deeper level. And so what they say is they actually show that if you just give the AI a few principles, like I don't want to be racist, I don't want to be misogynistic, I don't want to generate things about creating bombs or whatever, like dangerous items, that the model itself can introspect on the outputs that it's generating, and you can critique the responses that you're generating and generate training data like that. And so I'm going to skip over this in the interest of time, but the core insight is that if you generate a response, the model can generate a critique based on some constitutional principles, so based on some principles that you have. It can then look at that critique like, hey, this is, doesn't follow these principles because of this reason. Then you can say, revise the answer based on that critique, and the revision ends up being better than the original prompt. And so you have now a training data set where you have the original completion, and you have this new revised completion, and you know that this new revised completion, on average, is better based on those constitutional principles. So it's a really remarkable idea because you're improving one dimension of the model using the model itself. Okay, and they do this to basically, in this case, they do it to avoid harmful content. And so there's like hacking your neighbor Wi-Fi example here is an invasion of privacy, and then it revises that, thing. So what's awesome about fine tuning? Very powerful alignment tool. The quality improvements can be highly disruptive. So ChatGPT is based on this. And so although it's a lot of more work, it can lead to a fundamentally different product experience. Sometimes you want to train small models. They can be much faster. And there's methods to do things that aren't quite fine-tuning the whole model, something called, for instance, low-ranked adaptation, prompt tuning, which you're saying, hey, for these really big models, it's actually very costly to fine-tune the whole model. It's very then costly to serve this large model. So there's a lot of reasons why you don't want to fine-tune, kind of from practical considerations. But there are some interesting research that if you start to do this and those types of practical considerations become a problem, you can do it. The cons are, basically the cons are, I would say twofold. One is it's complicated, okay? So you're definitely building a team here to do this. And so, to take it on, take that into account. It's expensive, it requires a lot of labels. And the one other thing is I would say that is very important that you should consider with fine tuning generally, is that often you want to fine tune on your customer data. And that is highly problematic, right? Because guaranteeing privacy when you're training on customer data is not an easy problem. And so if you think, hey, I have a great proprietary customer data or data set, and you think I can't have this leak across customers, then fine-tuning becomes highly problematic. And you might want to think, no, I have to train on public data and then figure out a way to personalize the model to an individual person. Okay, so that leads to problem 2, which is prompt engineering. Tons of ideas around prompt engineering. So if you don't want to do fine-tuning, then the next answer is prompt engineering. And I would say lots of ideas here. I'm just going to breeze through a few cool ones. So this one is very simple. I would say just guidelines. This is an example of Bing guidelines for how Bing works, and just bullet point your preferences. As you see things that are going wrong, as things aren't working, just create a list of bullet points. I like that, you should do this, you should not do this, right? Don't write some big blob of text, just add and remove to your bullet points. This actually just works remarkably well and is something that a team can iterate. And if you look at how Bing Chat works, it works something similar to that, and it's very, very easy. Consider obviously using few-shot prompting, but one little trick on few-shot prompting is what should the few-shot prompts be? And so this is a paper here called What Makes Good In-Context Examples for GPT-3. And the core observation here is find examples that are similar to the task that you're doing at hand, right? And so one way to do this is create a database, sort of a golden database of examples, and then look up a nearby example using keywords or using embedding search, and inject maybe the 5 most relevant examples right into the context of your prompt that are relevant to the particular task at hand. And so you basically inject that. A lot of ideas in terms of how to do that particularly well, find similar examples, but also diverse examples. This paper is a great thing. So few-shot prompting, definitely consider it. Dynamic few-shot prompting is another thing that you can do to improve things. So that's great when you're using full-shot prompting. Another failure mode with many of these models is complex reasoning. 2 quick ideas and intuition to gain here is that for complex reasoning, there's a lot of evidence that if you give the model more time to think, it will do a better job. And so there's 2 types of prompting here. One type of prompting is called chain of thought prompting. And chain of thought prompting basically says, here's a standard prompt. It's a few-shot example prompt, question, answer, where it just gives the answer directly. Just in your few-shot examples, this is right what you put in your prompt, okay, and this is then what you complete. Just add the explanation of your logical reasoning path to that example, where you say, okay, I'm doing this math problem. Let me think like a little bit in terms of how my chain of thought goes. And by decomposing it, the model then when it writes its completion, it sort of has more time to decompose the problem. It sort of says, here's how I'm thinking about this. And you can think of that intuitively as like a scratch pad for the model, where the model is kind of thinking of doing its work. Or you can think of it as the model now spending more computational power on each individual answer. Rather than just saying, okay, right off the bat, one forward pass, I got to give you the answer. It's like, I'm going to generate a bunch of tokens, and those tokens might be helpful, and then I'm going to be able to look back at those, and now I'll give you my answer. And so you spent more computational power, and that leads to remarkably better performance in a lot of reasoning examples. Another example of this is a simpler example of this is you don't even have to give it examples. This is zero-shot version of chain of thought thinking. You can literally just start your completion with let's think step by step. And it turns out that this leads, if you just say answer, let's think step by step, and now completion, it will start thinking step by step, and it will sort of do what I just did in the previous slide without any examples. And you'll get like a 10% boost for these specific type of use cases. The awesome thing about prompt engineering is it's extremely flexible. So the pro is it's very fast. You can iterate like crazy. And then the second one, it's very simple to deploy. And the last one I think is that's often under appreciated is it's privacy preserving, right? You're not injecting, if you inject user context into the prompt, that is not leaking to other customers. It's just being used in that one completion, so you can put in anything you want about the user's data, the private data. You're not updating the model parameters. You're not leaking the data, so you can personalize in context. The downsides is it's a very kind of dark art, and there's millions of ways and hacks and twists and all this sort of stuff to do, and so it can be you can spend a lot of time doing that. Which gets to the third challenge, which I want to talk about with 5 minutes remaining, which is evaluation. So given that we're in a world where we're going to have to do a lot of prompt engineering, the question is how do we evaluate? And there's a lot of different ways to evaluate. I would say like often you want to evaluate product signals, which are coming from a product, like is the person accepting your suggestion or accepting your completion? That's, for instance, what GitHub Copilot does. They say, 30 seconds later, did the person keep this suggestion or did they edit this suggestion? That's an implicit product feedback. It's really nice because the user doesn't have to do thumbs up, thumbs down. Sometimes you have expert labelers internally that have an opinion, right? And you have an editorial decision, right? That might make sense in the case of that Yelp example. One idea, I'll only talk about one idea that you may not have thought about, which is AI evaluation. Just like that paper from Anthropic on constitutional AI, there's a lot of evidence that models themselves can evaluate themselves. And so you can actually figure out what response is better based on writing a prompt that actually evaluates the response. There's a great repository that OpenAI open sourced where it gives some examples of this. Just one, it's called OpenAI Evals. One specific example in the case of fuzzy outputs like hey summaries is literally just have a prompt like this, where you basically say your instruction, give it a response, then say your second instruction, give the second response, and then say, is the first better than the second, right? And you must provide one answer based on your subjective view. And actually, the model does a pretty good job of doing that. And so you can add some guidelines there and iterate on that, but basically you're trying to build a human rater that is a human rater. So I'm going to skip that. So problem 4, knowledge gaps and hallucination. This is a huge topic, but one of the problems with these models is that they don't have the knowledge about your own domain, and they often hallucinate knowledge, right? Where that means they make things up, okay? So the one idea, or the 2 papers that I'll just point out to that you should definitely, if you're interested in this problem, you should definitely read, is one is this paper called Retro, which is basically augmenting these deep models with search, and it's saying, hey, we can have a huge corpus of information that we have, and we can look up the answer and inject that answer into the prompt, right? And they do that with a sort of a vector search approach, and there's some twist to that particular idea. But they find, again, that the performance of these models dramatically improves versus their size if you can go and collect external data. The intuition here is these large models right now have to memorize everything. So they only know what they learned when they were trained on the internet, 2 years ago. And it's hard to memorize a lot of facts, right? So it's within your parameters of your model. And so this is saying, hey, let's have a nice thing that memorizes, namely search, and let's augment that with a reasoning engine, namely these models, and we'll get something good that results. Another paper here that's a very similar spirit, but is a little bit more of a tool use example is WebGPT, which is OpenAI's example of this. Bing Chat is an example of this. Let's teach the model how to use a tool to generate a search, inject that into the context, and then give the results. So retrieval-based context augmentation, that's what this is called. I would say the great thing about this is it's very easy and it's relatively easy to do if you just read these papers and see how they're implemented. And number one thing is it's privacy preserving. You can have data on your customers, you can index it, and you can look it up, and that can be very, very powerful. There are some downsides, like you can't fully reason over all the data that's in that external store, but you can get a lot of great results here. I only have 2 minutes left, so I'm gonna go very quickly. One extension of this idea, or last problem, is taking action, which is simply say often you want to automate your application or take action. And there's a paper here, there's a lot of papers here. The 2 most interesting ones are a paper called Toolformer from Facebook and a paper called React. And they're basically ways to use smart prompt engineering to allow the tools to make API calls. And you see this, the most recent example of this is ChatGPT plugins, which is an example of how do you use external tools. And the basic idea is you can have these models generate, hey, now would be a good moment to call search or to call this API. And you can give it examples of when it would be a good moment. And then you can watch for it it's saying, hey, I want to do a search, you can say stop generating, generate the search, inject the new information that I got from that search, and now complete the sentence additionally. And so Toolformer is an example of this, but there's also a paper called React. This is extremely powerful, can open up all sorts of examples. It does, of course, open up a whole bunch of caveats around giving models tools and making them act in the world without full control. So I would say be careful. So what can we do with, just to conclude, I'll do two last slides. What can we do with all this power? So I think there's four main areas. One is build cool features inside of your existing products, build copilots, that are similar, that are these things like GitHub Copilot, build category disruptors that are fundamentally new products or category creators, or disrupt an existing product, or build category creators that are fundamentally new products. Happy to talk with people in 108 around some of these ideas or questions around the earlier stuff that I went really quickly. I want to stop now because I know things are back to back here. And so I apologize for being a little bit rushed at the end, but I hope you got something out of this.